Hello everyone, I'm UofT from University of Toronto. Today I'm going to talk about our work, intra-operator scheduler for CNN acceleration. This is a joint work with collaborators from University of Toronto, Vector Institute, MIT, and CMU. CNN models are widely used in our daily life. It is important to efficiently deploy these models. However, is CNN inference in current deep learning libraries while utilizing the underlying hardware? The answer is no. Let's first look at the trend in CNN design. Here, we use VGNet, Inception v3, and NASNet as examples. People tend to use more convolutions in their network. However, the average convolution size decreased. On the other hand, the GPU peak performance increased a lot. We take NVIDIA Tesla GPUs as an example. The peak performance increased almost linearly with the time. Then let's have a look at the intra and inter-operator parallelization. Sequential execution is widely adopted by deep learning frameworks, which execute the operators one by one. The operator computation is parallelized through the threads in a GPU kernel. We call such kind of parallelization intra-operator parallelization. It can suffer from underutilization problem, especially when we execute a small operator on a powerful GPU. On the other hand, we can do the computation of multiple operators simultaneously. We call this kind of parallelization as inter-operator parallelization, which usually has a better device utilization. We use a concrete example to show this. In this example, the utilization of operator B is 33%, while the utilization of concurrent execution of operator A and B is 71%. What iOS does is to break the complicated problem that finds the optimal schedule for the whole computation graph into sub-problems that find the optimal schedule for subgraphs. This formula describes how this reduction works. I will explain each component in this formula through this example of computation graph. Here, S represents the operators of the computation graph that we want to schedule. We use latency S to represent the latency of the optimal schedule for S. To find the optimal schedule, we enumerate all potential last stage S prime and convert the original problem into a subproblem that finds the optimal schedule for operators S minus S prime. The subproblems can be recursively solved in the same way. In the same progress, we need to measure the latency of the last stage S prime. iOS explores the schedule space exhaustively in this way. The time complexity is n over d plus 1 and all of that parts 2d. Here, n is the number of operators, and d is the weight of the computation graph, which equals to the maximum number of parallel operators in the computation graph. For this model, we can concurrently execute operators E, F, and G, so d equals to 3 here. Then let's have a look at the evaluation. We compare iOS with QDN-based frameworks. All performance is normalized to the best framework. We compare iOS with TensorFlow, a state-of-the-art deep learning framework, and the TensorFlow XLA with a compilation optimization. Tassel is a transformation-based optimizer that uses transformation function-preserving transformations to find the most efficient computation graph. TVM is a state-of-the-art deep learning combination stack. Here, TVM QDN is TVM backed with the QDN convolution kernel. TensorRT is the NVIDIA-provided high-performance inference engine. iOS outperforms all QDN-based frameworks on all benchmarks and achieves 1.1 to 1.5 times speedup. This is because all baselines suffer from underutilization problem due to sequential execution. In conclusion, we found that sequential execution suffers from underutilization problem, especially when we execute a small operator on a powerful GPU. We propose inter-operator scheduler to utilize both intra and inter-operator parallelism. We employ dynamic programming algorithms to explore the schedule space exhaustively and prove that its time complexity is only exponential in the width of the computation graph, which is usually small, making the exhaustive exploration practical. iOS achieves 1.1 to 1.5 times speedup comparing to the state-of-the-art libraries. We have open sourced our code and welcome to check it out. Thank you.